What is NoSQL? NoSQL actually stands for Not Only SQL. This was a term coined by Eric Evans, and the reason he called it NoSQL was that in creating alternative to SQL or relational databases, you're trying to seek or solve a problem that RDBMS poses. Okay, whatever RDBMS is bad for, that's what we are solving with these databases. So it is a class of non-relational data storage system. And by non-relational, we mean that it does not adhere to the definitions of tables and thus does not have strictly rows or column definitions that are used in the relational data storage systems. It does not require a fixed table schema, nor do they use the concept of joins. All NoSQL offerings relax one or more of the ACID properties. Okay, we'll talk about those in a little more detail, but that's the biggest advantage we have of these. The reason or why the NoSQL? Because RDBMS cannot be all or end all. These are not the final or the perfect solutions. There are just too many different programming languages, and many of these languages again need some different solutions than a typical RDBMS solution. Even though that relational databases offer a very good general purpose solution to many different data storage needs, they are not a good fit for all of them. So a NoSQL solution is more acceptable to a client now than even a year ago. More and more people are shifting because their data needs are changing. The biggest reason why we had to shift to NoSQL was the explosion of the social media sites, such as Facebook, Twitter, and since these had large data and unstructured data, so we needed a different storage mechanism as well. Then there was the rise of the cloud-based solutions such as Amazon S3 simple storage solution, and these changed completely how we could store data and access data. So we could see that partitioning was no longer a solution when we had so huge a data amount. And that's something that the cloud-based solutions could provide us an alternative to. As newer and newer languages were created and most of these dynamically typed, we needed a shift to a dynamically typed data schema as well. Okay? And most of the open source community supported that. With the exception of the Amazon S3, almost all of the NoSQL schemas or NoSQL strategies are open source and thus provide a low cost entry point to a better solution or better data storage systems. Now let us discuss the different kinds of NoSQL. NoSQLs basically fall into two major areas, either the key value or big hash table kind, or the schema-less, which again can have multiple flavors such as column-based or document-based or graph-based. Even though this is not an exhaustive list, but these are just some of the well-known ones. In key value or big hash table scheme, you have things as the Amazon S3, Voldemort, Scleraris, and in schema-less, we have Cassandra, CouchDB, Neo4j, and HBase. HBase is the data storage solution for Hadoop as well. And this graph network is a database that uses edges and nodes to represent the storage data, such as the Neo4j. And in document or CouchDB, views are stored as rows, which are kept or which are accessed using the keys. And these can adapt to variation in document structure as well. So we have dynamic document structure in these cases. So here are some of the well-known ones. In key values, we have Redis, Triac, and in graph, we have Neo4j, HyperGraphDB. Document-oriented, we have MongoDB or CouchDB, and column family, we have Cassandra and HBase. Let's have a look at each one of these in a little more detail. The key value stores. Keys are mapped to possibly more complex values, for example, lists. So just as we had the concept of primary key in key value stores, again, we form some special keys, and these keys are mapped to a complete set or list of values. So just as we had a primary key and in the row of values, we've got something similar over here. The only difference is you do not have a table any longer. Keys can be stored in a hash table and can be distributed easily. So every key is, since every key is the entry point to your row, we create a collection of these keys that can be stored in a hash table. And thus, these are easily distributable. And such stores typically support the regular CRUD operations, the create, read, update, deletion operations. Okay? These are very close to the relational databases, thus they easily support the CRUD operations. However, they do not usually have joins or aggregate functions. Okay? Some of the well-known ones are Amazon's DynamoDB and Apache Cassandra. One of the most frequently or commonly used are the document stores. Document stores can be in some standard format, such as XML, JSON, PDF, or even offline Office documents. These documents are usually indexed. Okay? So they again have some key that is used as the identifier for these documents. And this allows these document stores to outperform the traditional file systems. This indexing helps us to quickly access them and do whatever operations we require on them. Some of the good things are that these are easily scalable. Okay, since each document contains its own key and value or a set of values, these documents can either be put in one collection or you can split them and have them on different servers. So the best thing is that they support scalability. Then this collection of documents can be in multiple formats. You can have JSON, you can have XML, and whatever framework you're working with, whatever languages you're working with, based on that, you can have a variety of the schemas as well. Then it also implements the ACID transactions and adapts some of the RDBMS characteristics, such as due to indexing. Those indexes work as primary keys, and you have the whole document attached to them. It supports query transactions, so the whole search and access is supported by them. Then since these are document-based, you can have design patterns, since those works on complete object notations, objects. So you can have those as well. Some of the common operations are field, range, and regular expressions. So these are very comprehensive solutions. These document-based are very comprehensive solutions that allow a lot of RDBMS properties, the good ones, to be used as well, where keeping it flexible enough for it to be used in